Hi, so welcome to the lab 4 on setting up of Kria board. So this is going to be an interesting lab session because this is the first time we're going to interact with the hardware. So here I have the hardware present with me which we'll be requiring. So here is your Kria board. Some of you might be using KR board as well. Then we have a keyboard, a mouse, the receiver for keyboard and mouse I have, and this is a Ethernet port which is giving it internet connectivity. You can, if you're doing it at your home, you can, or at your house, you can use the Ethernet port directly connected to the modem, or else if you're in the IPC lab or in some lab, you can connect it using the LAN ports which you are given here. All right. So in the lecture slides, we've already seen the the contents of like the architecture of this board, the MPSoft series, and more of it to be followed. But in this lab session, we're going to do a very hands-on session. All right. So I'll be using the internet web browser to explore and show you how we navigate through the entire documentation and how we burn the things. For this lab also, one thing which you need to know is we require an SD card. So it's preferable if you have two SD cards, even one SD card would suffice. For my convenience, I'll use two SD cards. So uh, all right. So let me open the browser window and start showing you the code. So the first thing which we'll be downloading is the operating system onto the SD card. So we have a Kria KV260 getting started guide available, and you can follow any of these documentations and it shows you how to get started with Kria KV260. It's showing you the Petalinux version, and there is an Ubuntu version of it as well. So you can use both. In fact, on this main page of Kria KV260, if you go, so I'm just showing you how the documentation of it is available. If you just type Kria KV260, then this is the home page of the AMD where it is present. So you will see that you can read about the board and the product features which we are having with this board: accessibility, flexible connectivity, DDR memory of 4 GB, and primary boot memory, general specifications like how many ultra RAM blocks it has, how many block RAM blocks it VRAM blocks it has, number of DSP slices, Ethernet interfaces, and primary boot device, secondary boot memory, image sensor processor, like what sort of support for there is there, what all interfaces are there on it, and what's inside you can see in the box, and then you can just click on get started guide, which will bring you to this page here. All right. And you can compare this to the KR260. Both are very similar in nature. So this is how the board looks like, and if you place this image in this direction, then this is what the board is actually looking like. All right. So there is a one-to-one correspondence between what you see here in the real life and what this board is showing you. So we have some Ethernet ports, some USB ports, HDMI port, a display port. We have fan power, IES connector, two IES connectors. We have a J2P mod port here, a UART JTAG port on the top, another JTAG port available here, Raspberry Pi camera connector available on top, and a micro SD card slot. So again, I'll show you that all these things which you see here is available on this board. KR260 is a little different in its terms of interfacing, but much of the things which we'll study is exactly the same. So you don't need to worry that I'm making videos on KV260 but I have KR, so it does not matter that much. So to begin, a computer with internet connection and with the ability to write to micro SD card is needed. So my computer directly has an SD card reader, but for some of you, you might require an SD card reader which looks like this. So It depends on how you boot, but this is how, let me just zoom into this a little bit. Alright, so Ubuntu 22.04 plus Ubuntu AI demos. So enable a desktop-like experience without the need of connecting to a laptop / PC, access to rich set of third-party software libraries in the Ubuntu community, and run the latest of several accelerated applications from the App Store to evaluate KV260. So you can setting up of the SD card image, you can do all that. We'll click on try Ubuntu. So it has already taken us to the next part, which is setting up the SD card image. So for this, we first of all need to download the Kria Ubuntu 22.04 desktop image. So if you're on we are Kria K26 so here there will be two versions available, KR260 and KV260. So you can download the version for this. The same version will work on Kria KR260 and KV260. So operating system will be the same. So I'll just download this image, and it might take some time to download for your case. For me, it's going to take 7 minutes. I have pre-downloaded, but since this is a latest copy, so I'll download the latest version of it. So we'll wait for this to get downloaded. In the meanwhile, while the Ubuntu image is getting downloaded, I want to bring your attention to the Petalinux build. So what Petalinux is you might study it differently, like you might go through many documentations, but simply put, it's a variant of Linux. And let me first of all open the page, Petalinux. So Petalinux is a variant of Linux which is specifically meant for FPGA platforms, and what it does is that if there's a normal Linux operating system, you can interact with your DDR memory, you can interact with your screen, keyboard, mouse, and all those kernels. But with the Petalinux, whatever IPs you have created in the PL section of your FPGA, that also you can access easily. So Petalinux tools uses the development of Linux-based products all the way from system boot to execution with the following tools. You have a command line interface, you have an application device drivers and library generators and development templates. You have a bootable system, image builder, debug agents, GCT tools, automated tools, and most important part is the custom board support package generation tools. And all these things you can, like embedded software, Linux and build tools, RTOS and libraries, soft processor cores, embedded ecosystems, all this you can actually do using Petalinux. So besides having the general command line interface and everything, you can access the hardware accelerated IPs which you have created using Vivado. So without wasting any time, let's go to another download which we want to make. So this is the documentation UG1354, and there is another documentation UG1414. So these are two technical documentations. One is Vitis AI library user guide and another one is Vitis AI user guide. So first of all, we'll be using Vitis AI library user guide. We'll be understanding this documentation, and today's lecture we'll be running some of the AI models which are available in the Vitis AI libraries, and then we'll understand Vitis AI in a more general format, and how to do optimization, quantizing, pruning, all these things which we've seen in the past. But for today's lab session, we'll be choosing Vitis AI library user guide. So some of you might be confused at what exactly are we trying to do. Is it Ubuntu, is it Petalinux, is it Vitis AI library user guide, what is it? So you have to understand that previously, before Ubuntu image was made, Petalinux was a general thing of running an operating system on any Zing based or MPSOC based FPGA produced by Xilinx. But after Ubuntu, so they have separate, like Petalinux has gone a little bit into the legacy mode, and Ubuntu, since it's more unanimously accepted and all the libraries and everything is available on it very easily. So starting from Kria boards, they have Kria K26 they have started to release an Ubuntu package for it. So we have an Ubuntu operating system, and on that we can load any of the hardware acceleration kernels which we want to write, and we can accelerate that along with running our operating system. On the other hand, Petalinux, you can deploy something which is known as deep learning processing unit on your FPGA. On the PL part, more of this will be clear if you see the video lectures, the theory lectures, that what exactly is deep learning processing unit. So we have a DPU running on our FPGA, which we can utilize. And a very easy way to do that, if one way is that you install Vivado, Vitis, and you create the you make a deep learning processing unit, you interface it with everything. But Xilinx people have already done all that, and they have created an image which we can directly burn and download at our end. So let's search for that. I'll just quickly zoom in into the to this little bit, and I'll make sure that my image is not blocking the things which I am referring here. All right. So in this documentation, you will see introduction, libraries and samples, programming examples, application demos, and we'll walk through this separately. Like we'll go through this entire documentation in one of the lectures. But as of now, we're interested in performing the lab session exercise, which is the practical hands-on work. So you can install the Vitis AI library from GitHub, but it is pre-installed on the board image which we directly are going to download. So let's scroll down to setting up the target. So there are 3 steps to set up the target: install the board image, install the AI model package, install the Vitis AI library package. And so there is a pre-built image for AMD platforms are available in the following locations. So the pre-built image for VEK can be downloaded from here. The pre-built images for all these boards, KV260 and everything, can be downloaded from are not updated to Vitis AI 3.5, so they are still at Vitis AI version 3.0. So but they've given the links from where we can download it. So ideally, because we're working on Vitis AI 3.0, we should switch this to 3.0 version, and then you can see that we directly have the option of downloading the KV260 from here. So we'll click, and this is the next file which you have to download. For this, you'll have to just sign into your, if you have not signed in, you have to create an account, and I'll anyways put these 2 files on the Google Drive, which you can internally share and keep downloaded. For me, I'm just downloading from here, and I'll put this in the download section. So while a file is getting downloaded, the second file will begin with the booting up of the Ubuntu image. So for that, we'll use a tool called Balena Etcher, and you can just download Balena Etcher. It's available for Windows, Mac OS, Linux, for all the operating systems. So you can just click on download. So now we'll just open this Balena Etcher and install this. Or so here it has directly opened, and we'll click on flash from file, and where we have downloaded our so this is the file which we have downloaded in the documents folder, and we'll click on this folder. Now we'll click on select target. So this image is of 9.58 GB, and the SD cards which you must be having is of either 64 GB or anything. So let me quickly take this out. Actually, a better way would be to So depending on your how you're going to flash it, I have in my computer a micro SD card slot, an SD adapter for this. So I'm going to use this to directly flash. So it has automatically detected the SDXC card, which is just installed, and you can see that this is selected, and I just need to click on confirm yes, and it will flash that SD card. So it will take around 9 to 10 minutes to flash the SD card. We'll just wait for that time. So while it is getting flashed, I'll just tell you what experiment we have to run on the Ubuntu. So um, we'll actually run an application called Kria KV260 Smart Cam. So there are two things which you want to do. One is the Smart Cam application which you want to run. So this is an inherent application available on the Kria KV260 board, and the architecture for it is simple. It will take audio interface from the PMOD if it is available. It will take the camera sensor input either from the 1335 sensor through this interface, MIPI interface, or we can directly take it from USB as well, or we can in fact input files as well through the SD card. And if it is coming through this CSI interface, then it needs to be decoded in a different way. If it is coming from a USB protocol, it needs to be pre-processed in a different way. And if it is coming from the SD card, then the stored video, it might be known that the MP4 format or any format, it has to be decoded. So there will be a VCU decoder which is involved before we can further send it for pre-processing. Then we'll do some inferencing on the DPU which is installed, and we'll select the region of interest, we'll encode it, and we can either send it through an RTSC protocol over the Ethernet port, or we can just display whatever is coming on the bounding box through an HDMI or the display port. So the smart camera implements face detection with network and display functionality, and it does it at a very good FPS. That's why it comes with a built-in machine learning for applications such as pedestrian detection, face detection, and people counting, with local display and RTSP streaming. So it's like a practical deployment, real life deployment of machine learning on embedded device. As I have said before, that it is very power efficient, it is very battery efficient, and also computationally very efficient. But what models are they using to detect the faces? All that information is stored inside the DPU. More of the same thing you'll be getting clarity in your theory lectures. Here we are wanting to test and actually do the hands-on work in the lab session. So we'll click on the next page. So you can read the entire, so this is a detailed pipeline of what is happening. First we are capturing the data from coming from different sources, and like we store it in the DDR memory and the video buffers. Then for the video pre-processing, we reading again from the DDR memory and doing the decoding and the encoding part as is when required. Then again we're storing it back to the DDR memory. From DDR memory we're picking up the acceleration thing, where we are doing the pre-processing, deep learning processing, and the post-processing, and we're again storing back in the DDR memory, and finally the output is picked whether it has to be stored in the files as a file in the file sync, or it has to be served over a web server using the real-time service protocol, or through the display port, and the audio which is optional, completely optional. So here you can see that it is color coded as PSPL and platform overlay VCU. So VCU is a separate entity in itself. As we had seen that in the PL, sometimes certain IPs are hard coded, so VCU is one of them. The DPU and the pre-processing part, the MIPI, CSI, all these things are happening on the PL, so therefore they are marked as yellow. The PS side, if we are taking as a USB camera, that is coming as white, or the file storage system, that is happening all in the PS, or even the post processing, so that is coming all in the white as PS. And since DDR is nothing but a board components, neither PS nor PL, so therefore This gray thing refers to the board component of DDR memory. So this is one sample, one application which we want to make. This is again a detailed diagram describing the architecture in the much more detailed level. But another thing which you want to do is actually run Pynq DPU. So we'll first of all actually, when we upgrade, when we install the Ubuntu, we'll install the Pynq on Kria KV260. For this, we'll head over to this repository of Kria Pynq, and there is a base overlay, a DPU Pynq overlay, and some composable pipelines. So Pynq actually is the Python utility for Zinc, which allows Python, which are basically Python wrappers built on top of the hardware libraries, and you very easily you can access the PL using your software. Like if you have to do something in the hardware, instead of writing it on the terminal or like doing it on the Vivado, you can simply write a Python code, and you can interact with your hardware completely. So this is, firstly, you have, even for getting the Pynq up and running, you have to update your Ubuntu. You have to get your Ubuntu working on KV260, and after that you clone this repository, and then you install the Pynq on that. So it will update certain files based on this installation script, and it will make your Ubuntu operating system even much more flexible. Besides running the Ubuntu operating system, you will be running with something which is known as Pynq, which will provide you a Jupyter notebook to interact with your entire board. So that is also very amazing. So we'll look at both of these things, and this is still downloading the DPU image, which will Petalinux build, which will help us run our machine learning codes out of the box, and the Ubuntu is much more utility based. So we see that there is an error coming, the writer process ended unexpectedly. So we'll try and see if what has happened, the issue. So it feels like that we'll just try this SD card once and try booting up. If it boots up, like the process has completed, I could not see like why the error has come, but let's try booting this up. So here we are, and this SD card which we have, we'll put this SD card in this slot. For the keyboard and mouse, I'll put the two USB receivers on the board itself. This is for the keyboard and this is for the mouse. And I've already connected it to the Ethernet port, so it has internet connectivity. So now let's start booting this up. Okay, so the issue which was coming is because of the latest release of Petalinux which we have downloaded. So it is recommended that you download a previous version of Petalinux, or you can use another, if you're on Windows, you can use another software which is known as Win32 Disk Imager. And so now I'll just switch to this scene. So you can see that in the KV260 we have the Ethernet, keyboard, mouse, HDMI cable connected. We have the correct SD card with the operating system, Ubuntu operating system, and we have this USB JTAG port which we have connected on this to the computer. So as soon as you connect that port onto the computer, let's switch to this view now, and you go into the device manager. Inside the ports, you'll see a COM5 and COM6 appearing. So those are the UART ports. So simply if you go over to MobiXterm is a utility which you can download, the portable version, and inside I'll just show you as well. MobiXterm, you can download the portable version for this, and inside the serial connection you can choose COM5 or COM6. Like for me it's COM5, and you can choose the speed as 11520. So all this is again uh, booting your start. It is mentioned here, like so after you've connected everything which is mentioned here, and you click on booting your starter kit. So for instruction for Windows, you first of all need to download these drivers. For you, most of these drivers will be installed. If not, it's a very simple thing to install this driver, and then you select this configuration. So inside advanced serial settings, this is by default, so you click on OK. I've already done that. So this is my system. So previously I was running it. As soon as I again power up my device, so I'll show you now. As soon as I power up my device, uh, the U-boot will start appearing here, and it will automatically boot the SD card. So U-boot is like the boot menu, and it inside that you can select which which interface to boot using. So this is basically selected to MMCM1, which refers to our SD card. So now the Ubuntu is loading up, as you can see in this screen, and simultaneously if I so as soon as it shows the display started, so you can see that the display started to come here as well on this screen. But mostly we won't be using the GUI any much, like we'll be referring to the command line tools. So this is just for your easy understanding, and I'll try to actually do most of the stuff with the command line itself. So let's switch back to the view. Whenever it's required, I'll show you here. One thing more which you need to see here is that at the default login credentials are Ubuntu and Ubuntu for you if you've just booted up the system, and the standard system policy requires you to change the password after the first time. So I want that everyone keeps a standard password which they can keep as IoT Lab 2240 on their systems, and to avoid any confusion and forgetting of the passwords. We'll verify the internet connectivity, and we'll set up the Xilinx development and demonstration environment by running this command on our system. So basically it's asking for us to log in, and if I show you the interface on the GUI is also loading up. So you can see that it is through the TTY PS1. We can also connect through the network SSH over to this. So that also is another possibility. So the default for this is Ubuntu, and the password which I have kept for my thing is IoT Lab 2240. So now we're logged in inside the board, and so at the same time, like as we've logged into this, you can see the GUI also has popped up, and but it's very slow to work with the GUI. Like you can log in using that, and it will give you a very similar interface. We can go inside that. So GUI takes time to load. Let me just show you once. So you can see that there is this GUI also which has opened up, and it looks like you can do all the things which you expect to do. You can click on open in terminal, and you will be operating just like an Ubuntu machine. But again, we'll resist from using the GUI, and we'll prefer using the command line. And because one of the smart cam applications which we will be running, that requires us to not, like the HDMI port will be using to display something else, so we won't be able to anyways use it after some time. At this point, we want to verify the internet connectivity. So let's ping this. So we are receiving data from that. That means we are connected to the internet on this. Also, you can look for the IP address of this by typing ifconfig. And in ifconfig, since I am connected to the Ethernet port, so you can see that this is the IP address which my router has assigned to the board. I can also verify that using the admin panel of my router. So if I log in inside my admin panel and I click on LAN devices, so you can see the name Kria has popped up with the same IP address. So if you have that IP address, you can connect to the board using VS Code as well. So you can actually connect to host, and you can click on configure SSH hosts, and just like this file, you can create a new file, like a new entry on this host, and you can call it let's say Kria. The host for this is the IP address which we are having. The username is Ubuntu and the password we'll enter when it is prompted. So we can save this, and once we try to connect to host Kria Linux, continue, it will ask us for the password, which we'll put IoT Lab 2240. So the main thing is of figuring out the IP address, and after that we can connect it via the SSH. So it was downloading the VS Code server onto the Kria board. So now we have SSH into our board, and with this SSH we can actually open the home folder of our board. Once again we'll have to enter the password, which would be IoT Lab 2240. Alright, and you can also run a new terminal on this. So now anytime you enter the commands, you will be you can run the commands here, and at the same time you can look at all the files which you have on the left side. So this is the best way to interact with any board. Let me just zoom into this a little bit for your easy viewing. But in order to connect to this to the board in this way, what basic thing you require is the IP address. So once you've done this, you can again head back to the starting of the kit, and there are certain commands which are mentioned that we need to run, like this command. So you can paste this command. For you it might take some time to install, because I am using old image which I was working on, so it's already installed. You can also click on setup script for Ubuntu. I have done this already, but just to show you, I'll do it once again. All this is possible once you are connected to the internet. Alright, finally running the smart camera application. So you can you can actually run these accelerated applications. So one of the things, there are two things which you have to do from this point onwards. You can click on evaluate free and you can submit the request, or more importantly, as I told you, that you can just click on actually the reference page of this. You can simply head over to the Google and write smart camera Kria. So it will take you to this page, and from here you can start with the setting up of the board and the application deployment. So it's telling you how to do that, and downloading the latest application firmware. So all these things you can search for, and first of all you need to search for the package feed. So that you can do by entering this command. Then you have to install the firmware binaries. So this is an application which is running both on the PS and the PL. So you can do that. Then you can disable the desktop environment. As soon as you do this Xilinx utility desktop disable, the GUI of the thing which we are seeing here, right here, this GUI will go away. So you have to be like, you're dependent on the your SSH thing after that only. So in this while the packages have been installed in this. Also while we are running this while we are running the smart camera application, and we can load the smart camera application. So in the lab you can now actually follow this. You can let this get completed. Also while we actually work on the smart camera application, so in the smart camera application, as I told you, first you have to enter this command, then install the firmware binaries, then disable the desktop. Then once you list the apps, you can unload the present app and can load the KV260 smart cam app. After that, once you have to install the Docker in your Kria board. So once you install the Docker and you click on Docker images. So once you've pulled this and you have the Docker images, you can see all the installed Docker image files, and you can run the Docker command with this code. So after the Docker is run, you will be inside this container, and here you can run the smart camera application. So you can download some of the files in MP4 format, and if you are on Ubuntu, then you can directly you can install FFmpeg, and you can convert the input file, whichever input file this is showing, into an output file, and you can see the results for yourself. Or what you can do is you can run the Jupyter notebook and can follow that. The Jupyter notebook, which also sets up the GStreamer pipeline as they have mentioned here. Or you can simply use the command line. So this allows you to define different video inputs and output device targets. So you can mention here the input file, the output file. So there are multiple ways to use that. If you are using MIPI input, then you can use these commands, and the output is one of this. So you can use these commands. If your input is USB webcam and you want to display it onto the display port or to the HDMI port, you can use this command in itself directly. And if you have to output it to a file, you can use this command. So here they have mentioned, so at this point you can see the result, but to see the file structure of the application, you can head over to this. You can head over to this file to see the smart camera's main app, the binary files, the script files of all the the script files to run this. You can see here the shell scripts file, and the configuration file, and the AI task, whether you want to do the face detection or you want to do the refined det, or you can do a single shot detection. You can do all of that. You can define it inside this AI. It is defined. One of these tasks you can see, The model files of all these are available inside the YTSA library models and the dense box 640 or the refined it or the SSD ADAS. So these are the different X model files which will be available inside this models folder. And you can also see the Jupyter notebook, which is the smartcam.ipynb notebook. So this is for the smart camera application which you can run. Alongside this, in the lab you'll also have to do Pynq Kria KV260. So as we had seen this example, so once you have installed and set up your Kria KV260, you can simply clone this repository and you can install using this code here. So for me, so this might take a while for you to actually download, so nothing to worry about. If you're doing it all this in the IPC lab and the Ethernet port, you might, before you disable the GUI in the smart camera application, you might want to connect to the internet using the GUI itself, because it's easier to connect to the bits internet using a GUI. So you just have to be or if it is coming directly for you over the Ethernet port, that is good. So next you just have to install the, you have to clone this repository, and if you see that for me it's already cloned here, and I'll just update this, or maybe I'll just using this install.sh script, sudo bash install.sh script. It will take around 25 minutes for you to for the Pynq to install. Once the Pynq is installed in this, you can actually access the Jupyter lab via the web browser of the IP address of the board, which we had seen earlier, :9090/lab, or you can simply type Kria 9090/lab. Kria is because even in the admin page we had seen the name of the device is Kria, so you can directly access it using the hostname itself, or you can, just to be very specific, you can give it the IP address also. Once you have done this, so you can simply head over to the so this is the base repository. You can simply head over to the base repository and you can try OpenCV filters with the face detection webcam, with OpenCV filters webcam. So you can give these applications a try. So now the process is completed, and you can see that the Xilinx environment setup is completed on this Kria board. So the next thing is, I had cloned this Kria Pynq repository some time back. So before running the application of SmartCam, I just want to install the Pynq and give you a glimpse of Pynq, which I would recommend you to get, because it's the easiest thing to understand and to utilize FPGA. So we'll just clone this repository and we'll follow the steps. So we'll do sudo bash install -b, and since this board is KV260, we'll just put KV260 as the board. IoT Lab 2240. So now it is installing the Pynq binary. So wherever the Python libraries are there, it will modify it, and so it will basically modify the operating system to incorporate the Pynq setup. And till that time, we can actually just go to the Pynq's home page. Sorry. Pynq.io, and so Pynq is an open source project from AMD that makes it easier to use their platforms, and it has the Linux operating system with Jupyter running on it, and you can see the Python's interface. So using the Python language, Jupyter notebooks, and the huge ecosystem of Python libraries, designers can exploit the benefits of programmable logic and microprocessors to build more and exciting electronic systems. So applications with parallel hardware execution, high frame rate video processing, hardware accelerated algorithms, real-time signal processing. So the Pynq has a support for many boards, including AMD's like Xilinx Zinc, AMD Zinc MP socks, and RF socks, Kria boards, Alveo boards, and you can actually go over through that. So there is this Pynq documentation which we'll follow, and you can see the supported boards. So either you can download the SD card image directly, but for some like Kriya, you have to actually upgrade the Ubuntu image. For others, you can just directly download this SD card image, which will have the board support package installed. And you can go through this Pynq. One thing which I want to actually explain is the base overlay. So Pynq ZC104, I think. Okay, so there is this concept of base overlay, and all right, so the base overlay has this kind of a design in which it incorporates a Vivado design which has all these things pre-installed in it, pre-made in it, using Vivado. Like there's an I/O processor, PMOD I/O processor, and HDMI in, HDMI out, audio mic in, GPIO, and the PSPL connection is also set up properly. All the things which are mapped to the PL, they are also interfaced directly. So you can just write a Python code to interact with this. So it's like a Python wrapper on top of a C wrapper. That's how the whole thing is structured. So this might take some as we had discussed 15-20 minutes. So till that time we'll pause the video. So while installing, there was this error which came about libvart runner.so cannot be opened. So I have just done sudo apt install -y vitessa runtime, and again I'll just do the build, sorry, not this command, but for the installation of Pynq, I'll execute this once again. So it will not take as much time, it will hardly take 3-4 minutes, so we'll just wait for that.